Welcome to Space Dreams documentary, where M87 star turns one orange ring into extreme reality tonight. Far beyond our galaxy, a colossal elliptical system glows quietly while something impossible anchors its heart. That ring seems simple, yet it outlines an invisible boundary where swallowed light leaves structure behind. Astronomers do not see the hole itself. They read brightness, shadow, and distortion around absence. Inference becomes awe when that measured darkness is placed inside a galaxy built on staggering proportions. M87 star is a multi-billion solar mass engine buried inside a giant galaxy where environment magnifies every consequence. The event horizon names the border, but the real story forms just outside that final limit. The ring is lensed light bent into geometry by gravity until space-time itself becomes visible. Its uneven brightness betrays relativistic motion, with one rushing side amplified into evidence of direction. To understand that asymmetry, the story widens from turbulent plasma to a planet-spanning act of measurement. Imaging M87 star demanded an Earth-sized eye, built by synchronizing distant radio observatories into one instrument. This was no ordinary snapshot, but a reconstruction assembled from interference timing algorithms and restraint. Once the image exists, the deeper question becomes what hidden motion reshapes the space around it. Real black holes spin, dragging space-time and making the region near the edge profoundly unstable. Polarized light reveals ordered magnetic structure, suggesting chaos near M87 star is threaded by hidden design. Those fields do not end at the ring. They organize a larger drama reaching far outward. The tiny shadow connects to a relativistic jet stretching thousands of light years beyond the galaxy. A swallowing object should seem passive, yet M87 star somehow helps drive beams of extraordinary power. Spin magnetic fields and infalling plasma may tap rotation itself, turning the abyss into engine. Yet the image leaves disputes: unresolved flow, geometry, spin strength, jet launch, and missing theory. So, M87 star matters because one ring turns theory into frontier where gravity meets knowledge's edge. Like, subscribe, and thank you for listening, because this impossible ring opens directly into part 1. It is one of the most famous images, and almost nothing in it is the thing people think they are looking at. The first picture of M87 star does not show a black hole the way a camera shows a mountain or a face. It shows the outline of a limit, a border written in heat-light motion and gravity so extreme that the object at the center cannot present itself directly at all. On April 10, 2019, when the Event Horizon Telescope collaboration released that blurred orange ring to the world, the reaction was immediate. Humanity had finally photographed a black hole. The statement was true. It was also smaller than the truth. Because what made the image historic was not merely that something invisible had been made visible. It was that an object long treated as the darkest prediction of Einstein's equations had forced the universe to leave a signature around its own silence. That leads to a larger question. If the first black hole image is really the visible trace of an invisible abyss, then what exactly is the image showing, and what had to be true about space-time light matter and measurement for that trace to exist at all? From a distance, M87 star looks modest. A ring, a dark center, a fuzzy halo of fire. But the calmness of the picture is deceptive. At its center sits a supermassive black hole in the giant elliptical galaxy. Messier 87, about 55 million light-years from Earth, with a mass around 6.5 billion times that of the Sun. Numbers like that arrive so often in astronomy that they risk becoming decorative. Here, they are structural. This is not just a large object. It is a gravitational regime so immense that human intuitions collapse before the black hole itself does. Yet the more unsettling truth is not its size. It is its restraint. Black holes are often imagined as cosmic vacuum cleaners, gluttonous monsters that suck in everything nearby. But gravity does not work that way. A black hole is not magic hunger. From far enough away, it pulls like any other mass. The real weirdness begins at terrible proximity, where space-time becomes so deformed that escape itself stops being a possible future. That threshold is the event horizon. And the event horizon is where the story stops behaving like common sense. This is the first trap in the image of M87 star. People think they are seeing the black hole itself as a dark disk inside a glowing ring. But the black region is not a surface, and the ring is not a neat border painted around some hole in space. What we are really seeing is the result of hot plasma orbiting close to the edge light, being bent by intense gravity and a shadow larger than the horizon itself, created by the black hole's effect on the paths light can take. The picture is already a distortion before we ever look at it. The black hole does not just sit there in darkness. It reorganizes reality around it. Light that should have traveled elsewhere is redirected. Gas that should have remained a diffuse cloud is accelerated, compressed, heated, and forced into a violent choreography near the edge of no return. The bright ring is the aftermath of that choreography. It is the universe under pressure. This is why the first image matters as more than a symbol. It is not a trophy shot. It is a measurement of deep structure. General relativity predicts that around a black hole, gravity should lens the surrounding emission into a ring-like form of a certain size. The ring around M87 star appears where theory says it should. That is why the image became a test, not merely a spectacle. The picture is beautiful, but beauty is not the scientific point. The point is that a human theory written on paper generations earlier survives contact with one of the harshest environments in the known universe. Even so, the easy explanation still fails. Because saying that astronomers took a picture of M87 star hides the real difficulty, and the difficulty is part of the meaning. Observatories scattered across Earth were linked into a planet-sized radio telescope. Signals had to be captured with atomic clock precision. Vast amounts of data had to be recorded, transported, correlated, calibrated, and reconstructed. The final image did not emerge from one shutter click. It emerged from synchronization across continents, from mathematics, from inference, from discipline. The image is about two frontiers at once. One is the frontier around the black hole. The other is the frontier of what a civilization can force itself to measure. That dual story is easy to miss because the ring is so visually simple. But simplicity here is earned. It is what remains after enormous complexity has been compressed into something legible. And even then, the simplicity is unstable. The ring is brighter on one side than the other. That asymmetry is not cosmetic. It tells us that matter near M87 star is moving at relativistic speeds, so fast that motion changes the apparent brightness. The picture is not still. It is frozen violence. This should already change the way the image is understood. The first black hole ever imaged is not presented to us as a neat object with clean edges and settled meaning. It arrives as a battlefield between visibility and invisibility prediction and measurement order and distortion. It says here is a place where gravity does not merely pull. It governs what can be seen, what can be inferred, what counts as a boundary, and what it means for an object to have an appearance at all. That is why M87 star became more than an astronomical milestone the moment it entered public memory. It turned a black hole from an abstraction into a visible argument. We can still read the edge even when the center withholds itself. But that only deepens the next problem. Because once the image proves that the shadow is real, the obvious question is no longer whether black holes exist. It is why this black hole in this galaxy produces not just a shadow, but one of the most powerful jets in the nearby universe, as if the same object that traps light can also help launch energy across intergalactic space. A black hole becomes easiest to believe in at exactly the moment it becomes hardest to understand. Once the ring around M87 star enters the public imagination, the mind wants to settle the matter. Fine. There is the black hole. There is the glowing gas around it. Problem solved. But the image does not close the question. It opens a more difficult one. How do you see something whose defining property is that it does not let light escape? The obvious answer is that you look at what surrounds it. The real answer is harsher. You do not see the black hole itself in any ordinary sense at all. You see a failure mode of light. You see matter being forced into brightness by gravity. You see trajectories that should have gone elsewhere get bent into new paths. You see an absence made measurable because everything around it has been pushed out of shape. That is why the first image of M87 star is not a triumph of vision alone. It is a triumph of reading distortion. Astronomy has always depended on indirect knowledge. Nobody touches a star. Nobody visits a quasar. Even nearby planets were understood first as points of wandering light before they became worlds. But black holes push this logic to its limit. A planet reflects sunlight. A star emits light from its own furnace. A cloud glows, absorbs, or scatters. A black hole offers no such cooperation. It announces itself by refusing to announce itself. If isolated in empty space, it would be almost impossible to detect. Only its gravity acting on other things gives it away. This is why the environment of M87 star matters so much. The black hole is not sitting in clean emptiness like an object on display. It is immersed in a violent region of magnetized plasma. In falling gas turbulence, compression, and orbital motion near the threshold, where space-time itself becomes the main architect of what can happen. That environment does not simply decorate the black hole. It is the only reason the black hole becomes legible. The bright emission around M87 star comes primarily from superheated matter near the event horizon, especially radio emission from electrons spiraling through magnetic fields. The heat is immense, but heat alone is not the story. Motion matters, geometry matters, perspective matters. Near a black hole, light does not travel in the straight obedient lines that common sense expects. The space-time around the hole is curved so severely that photons can be deflected, delayed, captured into orbit, or sent looping around the dark center before escaping toward Earth. The result is that the visible structure around the black hole is not a simple map of where the glowing gas sits. It is a lensed construction, a rearrangement imposed by gravity. This is where the language of a shadow becomes important. The dark center in the image is often called the black hole's shadow, and that word is more precise than it first sounds. It is not the event horizon drawn directly for us, like an outline on a diagram. The shadow is larger than the horizon because it includes the region from which light rays are captured rather than escaping. In other words, The black region is a record of which paths have been erased from the sky. The black hole does not present a face. It subtracts futures from light, and the shadow is the visible consequence of those missing options. Once that is understood, the image becomes stranger. We are not just looking at something far away. We are looking at a place where the menu of possible trajectories has been rewritten. Space-time is no longer passive background. It is the active machine controlling the scene. This is the deeper reason black holes matter in modern physics. They are not merely heavy objects. They are extreme tests of what reality allows. Near M87 star gravity is not one force among many. It dominates the terms of visibility itself. And yet, even here, the image stays incomplete. The ring is not a rigid circle carved in stone. It is an observational average, a structured glow shaped by changing plasma flows, lensing and emission patterns. The famous picture looks stable because the final product had to extract durable features from a difficult signal, but the region it represents is dynamic, restless, and unstable. The surface impression is serenity. The underlying truth is turbulence. That tension is part of what gives the image its power. It looks like a symbol, but it was born from chaos. This also explains why the image had to be made in radio wavelengths rather than visible light. The center of M87 is not presented to us as a neat optical target. Dust gas and the scale of the black hole's emission make radio observations the right tool, especially at wavelengths that can resolve horizon-scale structure when combined across Earth-sized baselines. So even the act of looking is already a compromise with physics. Humans did not point ordinary eyes at M87 star and discover a ring waiting politely in the dark. They built an artificial way of seeing appropriate to the object. That is a much deeper achievement. It means the image is not just about a black hole existing out there. It is about a species learning how to make the universe answer questions in a language beyond instinct. But the answer creates pressure of its own. Because once darkness can be measured, it stops being only a void and starts becoming geometry. Once geometry appears, motion becomes the next hidden layer. The uneven ring around M87 star is already hinting that the black hole's surroundings are not just bright. They are moving with extraordinary speed. And once motion enters the image, the story has to shift again away from the existence of the shadow and toward the violence of the matter that makes the shadow visible in the first place. The black hole is not the only giant in this story. That is the first correction the image of M87 star forces on anyone who lingers long enough. The orange ring became famous because it looked self-contained, as if the object at the center could be understood on its own, isolated in darkness, detached from the rest of the galaxy that shelters it. But M87 star does not live in emptiness. It sits inside Messier. 87, a colossal elliptical galaxy in the Virgo cluster, one of the largest and most massive nearby galaxies humans can study in detail. The black hole matters because it is extreme. The galaxy matters because it explains why that extremity became possible in the first place. The story on the surface is an image of a black hole. The story underneath is one of accumulation structure and scale. A supermassive black hole is not simply born large and left unchanged. It becomes what it is through a long history of feeding mergers, collisions, and galactic life. M87 is the kind of galaxy that can sustain that history. It is old, immense, and crowded with stars. It dominates its local environment with the heavy authority of something that has had time to gather mass and reshape its surroundings. And at its center, where the galaxy's structure deepens into a dense gravitational core, M87 star has grown into one of the most formidable black holes ever directly studied. That matters because people often imagine black holes as exceptions to the universe, freak objects that break the normal story. But M87 star is not outside the story of its galaxy. It is one of the main ways that story becomes visible. Long before the 2019 image, M87 was already famous for something else, a spectacular jet of material blasting outward from its center across thousands of light years. That jet was the clue that the nucleus of M87 was not quiet. It was active, violent, engine-like. The galaxy had been advertising its central power for decades before the black hole's shadow was ever resolved. This changes the emotional logic of the image. The ring was not the first sign that something extraordinary lived there. It was the first time humanity forced the hidden source of that activity into a measurable silhouette. In other words, the image did not reveal a surprise in the strict sense. It revealed the mechanism beneath a spectacle that had already been on display. This is what makes M87 star such a perfect target and such a dangerous one for the imagination. It is easy to think of the jet as a side feature, a bonus effect, a dramatic flourish attached to the main object. But the jet means the black hole cannot be understood as a silent sink. Matter falls inward, yes. But somehow, in a process not yet fully settled in every detail, the region around the black hole also helps collimate and launch energy outward at enormous scales. The object that traps light is somehow implicated in one of the brightest, fastest, and most extended structures in its host galaxy. That contradiction sits at the heart of M87. Devouring and launching, darkness and radiance, capture and release. It is exactly the kind of contradiction that turns an astronomical object into a narrative engine, and it explains why M87 star came before the black hole at the center of our own galaxy in the public story of black hole imaging. Sagittarius A star is much closer to Earth, but M87 star offers an observational advantage hidden inside its enormity. Because it is so massive, the characteristic timescales near its event horizon are slower. The glowing material around it changes more gently. Its appearance is steadier. The black hole at the center of the Milky Way flickers and evolves on faster timescales, making it harder to reconstruct into a clean image. M87 star is farther away, but in a deeper sense it is calmer. The easy explanation is distance. The real explanation is timescale. That is the kind of reversal black holes force again and again. What seems nearer is not always easier. What seems larger is not always more chaotic. Scale does not merely intimidate measurement. Sometimes it stabilizes it. That observational advantage does not make M87 star simple. It makes it possible. There is a difference. The black hole is still surrounded by hot plasma, strong magnetic fields, relativistic motion, and intense gravitational lensing. But because the structure evolves more slowly, the Event Horizon Telescope could synthesize a persistent image rather than chasing a blur that changed too fast to hold. This means the first black hole image did not go to the closest target or the most familiar one. It went to the one whose physics made patience possible. That alone should sharpen the meaning of the achievement. Humans did not photograph the nearest abyss. They photographed the abyss whose behavior could be decoded first. Even the galaxy around M87 star adds weight to this logic. M87 is not a spiral galaxy like the Milky Way with delicate arms and broad lanes of star formation. It is a giant elliptical system, swollen, luminous, and structurally different, shaped by a long and probably violent history. It feels less like a pinwheel and more like a kingdom of accumulated mass. M87 star belongs there. The black hole is not an ornament at the center. It is part of the architecture of power. And once that becomes clear, the image itself changes again. The ring is no longer merely the first portrait of a black hole. It is the visible mouth of a much larger machine embedded in a giant galaxy whose central engine has been shaping its surroundings for ages. That is the deeper setup. Because once the black hole is understood, not as an isolated darkness, but as the core of an active system, the next question becomes unavoidable. If M87 star helps drive a jet that stretches across thousands of light years, then the crucial story is no longer just where the event horizon sits. It is what the region just outside it is doing, with matter motion and magnetic fields under the most extreme conditions nature allows. The event horizon sounds like the main event, because it is the line that never lets anything come back. In popular imagination, that is where the black hole becomes a black hole. Cross that border and the story is over. Stay outside it, and the universe still belongs to you. This is true in one sense, and deeply misleading in another. Because the event horizon is not the part of M87 star that we actually see doing the most visible work. It does not glow. It does not announce itself with a hard edge. It does not behave like a wallless shell or a cosmic surface that incoming matter splashes against. The real spectacle happens just outside it in the last region, where matter can still orbit, light can still escape, and information about the scene has not yet been erased from the rest of the universe. This distinction matters because human intuition keeps trying to put the black hole where the brightness is. The ring around M87 star encourages that mistake. It looks as though the object is outlined by fire, as though the black hole were wrapped in a luminous border that marks its body. But a black hole has no visible body in that sense. There is no solid surface to strike, no crust, no furnace skin, no glowing shell. If matter fell onto a neutron star, it would crash into something. If matter falls toward a black hole, there is no final impact visible to the outside universe. There is only descent acceleration, heating distortion, and then disappearance. This is why the region just outside the event horizon matters so much. It is the last place where the universe is still willing to tell us what is happening. That last place is not calm. Gas near M87 star is compressed, magnetized, and driven into motion by the black hole's gravitational field. Some of it spirals inward through the accretion flow, rubbing, colliding, and heating as angular momentum is redistributed. Some of it is tangled with magnetic fields so intense and structured that they help organize the plasma rather than merely decorating it. Close to the hole, orbital speeds become enormous fractions of the speed of light. Light is emitted, bent, delayed, and redirected. The black hole itself remains dark, but the region around it becomes one of the brightest and most violent environments a galaxy can host. The place defined by no escape becomes legible only because the surrounding matter is driven into such extreme visibility. The event horizon itself is also stranger than the phrase suggests. Horizon sounds geographical, like the line where land meets sky. But this horizon is not a feature in space alone. It is a feature in space-time, a causal boundary. Outside it, some future paths still lead away from the black hole. Inside it, every future path leads inward. That is the real brutality of the horizon. It does not merely block retreat. It rewrites what forward means. Once that is understood, the border becomes less like a fence and more like a change in the structure of possibility. Yet even this description can seduce the mind into thinking the horizon is the thing to stare at. It is not. The horizon matters because of what it forces nearby matter and light to do before they reach it. There is another hidden layer here. Not every orbit near a black hole is equally possible. Faraway matter can circle in relatively stable paths, move inward, and those options narrow. Near enough stability fails. The easy story is that things simply spiral into the hole because gravity is strong. The real story is harsher. There comes a region where space-time no longer permits long-term orbital compromise. Matter can whirl there briefly, but the balance becomes precarious. A slight loss of energy, a collision, or a magnetic shove, and the plunge begins. This is why the inner edge of the accretion flow matters. It marks the transition from troubled survival to terminal fall. The black hole is not merely pulling matter in, it is stripping away the possibility of lasting resistance. This is also why M87 star does not appear as a neat diagram in the sky. The ring we see is shaped by emission from plasma in this last visible territory, but also by the trajectories available to light itself. Some photons escape directly. Others loop around the black hole before emerging. Others never emerge at all. Near the black hole, light is no longer just a messenger carrying a passive report. It becomes part of the dynamical story. Its route has to be earned. And because those routes are sorted by gravity, the image that reaches Earth is already filtered by which photons survive the geometry. That means the region just outside the horizon is doing two things at once, generating the light we observe and deciding which of that light is allowed to matter. This is where the first image of M87 star becomes philosophically unsettling. It looks like a picture of an object, but it is more accurately a map of permissions. Where can matter still orbit? Where can light still escape? Which trajectories remain open and which have been sealed shut? The ring is the visible answer to those questions. It records the last negotiable zone before the black hole's accounting becomes absolute. That is why the edge is the story. Not because the edge itself shines, but because everything that can still be seen has been compressed into a narrow arena where gravity is deciding moment by moment what remains observable. And yet, even this is not the deepest layer. Because once the event horizon is understood as a causal border and the surrounding brightness as a product of matter under extreme stress, the next problem becomes impossible to ignore. The ring is not only bright, it is shaped. It is not only shaped, it is distorted in a very particular way. That means the crucial actor is no longer just the plasma outside the horizon. It is the geometry through which its light must travel. The black hole is not merely surrounded by glowing matter, it is sculpting the appearance of that glow with gravity so severe that the image becomes an argument about space-time itself. The ring around M87 star is not a border drawn around darkness. It is a negotiation between light and geometry is winning. That is the deeper correction. By the time the first image reaches human eyes, the scene has already been rewritten by gravity so thoroughly that the picture is no longer a straightforward record of where things are. It is a record of how the black hole forces light to move. This is why the image feels so clean and so uncanny at the same time. The glowing structure around M87 star is real, but the form in which it appears is not simply the raw shape of hot gas circling a compact object. The black hole has intervened. It has bent the routes, magnified some regions, hidden others, and turned emission from a violent plasma flow into a ring-like signature that can only exist because space-time near the hole has become an optical machine. The easy explanation is that the black center is the hole and the bright ring is the stuff around it. The real explanation is that the black center is a shadow produced by lost light paths, while the ring is partly built from photons that have survived a labyrinth of curvature. That difference is everything. Near a black hole, light does not enjoy the freedom it has in ordinary space. It travels along the structure space-time allows a near M87 star. That structure is so deformed that some photons can whip around the black hole before escaping. Some can skim regions of unstable orbit, and some are doomed entirely. The result is not just dimming, it is architecture. Gravity turns the visible scene into a shaped field of possible and impossible trajectories. That is why black hole imaging is so conceptually powerful. It is not only that we detect hot matter near an invisible object, it is that the invisible object imposes a pattern on visibility itself. This can be hard to feel because the final image looks soft and almost simple, but simplicity here is deceptive. Imagine trying to reconstruct a city by looking only at echoes in a warped hall of mirrors where the mirrors are moving. Some echoes loop back on themselves, and some corridors lead nowhere at all. That is closer to what the black hole is doing to the light around it. The image is not a natural snapshot waiting patiently in space. It is the surviving output of a system that heavily edits its own appearance. This is why the term photon ring became so compelling in public discussion, even though the reality is more layered than a single glowing loop. There are photon trajectories near the black hole that graze extremely curved regions and can wrap around the hole before escaping. Those paths contribute to the apparent concentration of light near the edge of the shadow. But the observed ring is not a single pure thread from a single simple orbit. It is a broader emission structure shaped by plasma lensing motion and the black hole's space-time together. The obvious explanation wants a crisp circle generated by one mechanism. The truth is more demanding. Several layers of physics pile on top of one another until the final structure becomes readable. That does not make the ring less real. It makes it more profound. It means we are not seeing a decorative edge. We are seeing multiple physical processes collapse into one visible consequence. The shadow itself deepens that consequence. If the event horizon were all that mattered, the dark region would correspond neatly to the boundary of no escape. But the shadow appears larger because it is determined by the capture of light, not just by the location of the horizon. The black hole's influence extends outward into the field of vision, claiming not only matter, but options. There are routes photons could have taken in a gentler universe that are simply unavailable here. This is what gives the shadow its authority. It is not merely where the black hole sits. It is where the black hole has erased possibilities from the sky. Once you see the image, that way, the emotional force changes. The ring stops being an outline and becomes a verdict. Space-time has judged which rays live and which rays die. And yet, the most remarkable part is that this verdict can be measured at all. General relativity, a theory often introduced with clocks falling objects, and bent starlight reaches all the way into the furnace of M87 star, and still has something definite to say about the size and structure of the shadow. That is what turns the image from a beautiful curiosity into a confrontation between theory and reality. A black hole is one of the last places where intuition should survive, and yet mathematics predicts a visible geometry there. The universe answers by producing it. Still, the ring does not close the case. It intensifies it. Because once gravity is understood, not merely as a pulling force, But as the sculptor of the image, the black hole becomes more than a hidden mass at the center of a galaxy. It becomes an instrument that reshapes all surrounding evidence. The question is no longer just what the black hole is doing to matter. It is what it is doing to appearance itself. And that leads directly to the next fracture in the simple story. The ring is not evenly bright. One side is more intense than the other, as though the black hole has tilted the image toward motion. That asymmetry is not a flaw in the photograph. It is the next confession the system is making. The light around M87 star is not only bent, it is being emitted by matter moving so fast that motion changes brightness direction and what becomes visible first. The ring around M87 star is not only a shape, it is a speed map disguised as an image. That is the next collapse of the easy explanation. Once people accept that the glowing structure is not the black hole itself, but light from hot matter near it, the mind still wants relief. Fine then, the ring is just the gas around the hole, bright all the way around, a circular furnace enclosing a dark center. But the image refuses that comfort too. One side is brighter. One side seems to lean toward us with more force, more intensity, more visual authority. The asymmetry is not an accident of color, a smear from imperfect instruments, or a meaningless blemish on a historic picture. It is one of the deepest clues in the entire image because it tells us the black hole's surroundings are not merely glowing. They are moving at relativistic speed, fast enough that motion itself changes what brightness means. This is where the story shifts from geometry alone to geometry plus velocity. Gravity sculpts the possible paths of light, yes. But the plasma near M87 star is not standing still while those paths are bent. It is orbiting, plunging, twisting through magnetic fields and carrying enormous energy around the black hole in a regime where Einstein's rules alter not only the route light takes, but how light from moving matter is boosted or diminished depending on direction. The side of the flow coming toward us appears brighter because motion compresses the emitted radiation into greater intensity along our line of sight. The side moving away appears dimmer. The ring is not evenly lit because the environment around M87 star is not a peaceful halo. It is an engine under differential exposure, and relativity lets us see which side of that engine is advancing into view. This matters because it turns the image into something more than a proof of existence. It becomes a diagnostic. A black hole image is often described as though it answers. One simple question: is the black hole there? But the uneven brightness answers a more demanding question. What is the matter around it doing? The real achievement is not merely that humans isolated a shadow. It is that the image preserves directional information from a region so extreme that the ordinary meanings of position and appearance are already unstable. Motion writes itself into the ring. That should feel astonishing, because the area involved is tiny on cosmic scales and impossibly distant from Earth, and yet the image still carries evidence about which side of the flow is effectively rushing toward us. The universe is not merely allowing the black hole to be seen, it is allowing the dynamics around it to leak through. That leakage is invaluable. Matter orbiting near a black hole does not just move fast in some casual sense. It moves at a substantial fraction of the speed of light. At those speeds, the familiar intuitions that work for planets, cars, storms, and even stars begin to fail. Light from material headed toward the observer is relativistically beamed, concentrated, made more prominent than it would otherwise be. Light from the receding side is comparatively suppressed. This means the ring around M87 star is not simply a circle of equal emission. It is a contest between intrinsic glow and relativistic presentation. What we see depends not only on where the plasma is, but on how fast it is moving, and in what direction relative to us. The image is therefore not a passive portrait. It is an argument made by motion. It says this environment is organized directional and violently fast. It also says something subtler. The asymmetry proves that the image cannot be treated as a decorative icon detached from underlying physics. If the ring were perfectly uniform, the public imagination could more easily reduce it to symbolism, a cosmic logo for the idea of a black hole. But the uneven brightness resists simplification. It pushes the viewer back into mechanism. Why that side? Why that intensity? What kind of flow produces such an imbalance? The picture becomes less like a badge and more like a system caught in the act of revealing itself. This is the recurring pattern with M87 star. Every time the image seems to settle into a stable meaning, a deeper layer disturbs it again. The black center becomes a shadow rather than a surface. The ring becomes lensed emission rather than a border. The brightness becomes velocity rather than decoration. Surface interpretation keeps collapsing into harder truth. Even the phrase coming toward us is more slippery here than it sounds. The matter around M87 star is not a simple wheel rotating in a flat, obvious plane like a coin spun on a table. It belongs to a complex, turbulent, magnetized environment near a black hole that likely spins, drags space-time, and helps organize the accreting material into structures more complicated than any clean classroom diagram. Yet the relativistic brightening still emerges strongly enough to leave its mark on the image. That is what gives the asymmetry such force. It survives complexity. It survives turbulence. It survives all the inferential difficulty between Earth and the event horizon scale region. It is a durable clue in a place built to destroy clarity. And once that is recognized, another consequence follows. If the ring can preserve evidence of direction and speed, then imaging M87 star is not just about resolving a static object. It is about extracting physical truth from a moving, changing relativistic environment at the edge of the observable limit. That turns the question outward toward the instrument itself. What kind of telescope could possibly detect a pattern this delicate from 55 million light-years away? What kind of measurement system could distinguish shadow lensing and relativistic brightening at a scale smaller than the solar system across intergalactic distance? The black hole is extreme, but the method needed to read it may be the next true shock. Because before the world could debate what the ring meant, humanity first had to build something close to impossible, an eye the size of Earth. The first image of M87 star looks simple because the machinery required to make it is almost absurd. That is the next reversal. A blurred ring of light reaches the public, and the human mind naturally assumes that somewhere there must have been a very powerful telescope aimed very steadily at a very distant target, collecting a very difficult but basically ordinary photograph. That story is comforting. It is also false. No single telescope on Earth can resolve the event horizon scale structure of a black hole 55 million light-years away. The object is too small on the sky, the target too demanding the physics, too unforgiving. To see M87 star at all, humanity had to stop thinking in terms of one instrument and start thinking like a planet. The Event Horizon Telescope is not a telescope in the everyday sense. It is a network of radio observatories distributed across Earth, linked by timing precision so severe that continents have to behave like parts of a single optical system. The obvious explanation is bigger lens, better picture. The real explanation is stranger when the universe hides its most important structures behind impossible angular scales. You do not simply build a larger machine. You synchronize many machines until the whole planet begins to act like one. This is the meaning of very long baseline interferometry, though the phrase can sound colder than the achievement deserves. Telescopes in different parts of the world observe the same source at the same time, recording the incoming radio waves with exquisitely accurate timestamps provided by atomic clocks. Later, those signals are brought together and compared. Tiny differences in arrival time encode information about the structure of the source. In effect, Earth becomes a measuring device with a baseline as wide as the spacing between its observatories. That is how a civilization extends its sight beyond what any single mirror could ever do. But even that description risks sounding cleaner than reality, because the image of M87 star is not simply captured. It is assembled out of scarcity. Observing at millimeter wavelengths is brutally difficult. The atmosphere interferes. Water vapor corrupts the signal. Weather matters. Sight conditions matter. Instrument stability matters. The target must be observed across multiple stations, separated by oceans and mountains, all of them functioning well enough at the same time for the data to be worth combining. The black hole does not offer second chances on command. The Earth has to cooperate. The sky has to cooperate. The machines have to cooperate. And then, after all that, the data are still not a picture in any ordinary sense. They are fragments of information about spatial frequencies, partial samples of a structure that has to be inferred. This is why the image of M87 star is not a snapshot, but a reconstruction, and reconstruction is not a weakness here. It is the entire point. Nature does not hand over an event horizon scale scene in convenient visual form. Humans have to extract it from interference patterns, calibration procedures, statistical discipline, and model testing, severe enough to guard against self-deception. That last part matters more than the romance of the engineering, because once the public hears that the black hole image was reconstructed from sparse data, doubt naturally enters the room. Was the ring really there, or did the algorithms paint it in? The question is fair. The answer is what makes the achievement so strong. Independent imaging methods. Different teams and different reconstruction strategies converge on the same basic result. A bright asymmetric ring surrounding a central dark region of the expected size. The image is not arbitrary artwork manufactured from noise. It is what survives repeated attempts to extract a stable truth from incomplete evidence. In that sense, the real heroism of the Event Horizon Telescope is not merely technical. It is epistemic. It is a system designed not just to see, but to resist fooling itself. That makes the image more impressive, not less. Many scientific breakthroughs depend on indirect inference, but black hole imaging pushes that idea into a psychologically uncomfortable zone. Humans trust photographs because they feel immediate. M87 star had to be earned through a much more disciplined form of trust in synchronization, in calibration, in consistency across independent methods, in the fact that reality leaves the same scar in the data, no matter how many careful ways you try to read it. The picture is persuasive, precisely because it is not naive. It comes out of a method built for objects that refuse to be straightforward. Even the physical handling of the data adds weight to the story. The recorded information is so vast, and so timing sensitive that it cannot simply be emailed around the world like a normal dataset. It has to be stored on physical drives and transported for correlation. There is something almost archaic hidden inside the most advanced black hole image ever made. The future of astronomy still depends, at one stage, on humans moving matter through the world. That detail feels small, but it reveals the scale of the undertaking. This is not a neat digital miracle performed weightlessly in abstraction. It is global infrastructure wrestling with one of the hardest targets in nature. And yet, the greatest conceptual shift is still ahead. Because once Earth has been turned into an eye, once sparse signals have been forged into a ring, the meaning of the image changes again. It ceases to be only a proof that M87 star exists. It becomes proof that horizon-scale gravity is experimentally accessible. That is a profound threshold. For generations, black holes occupied the borderland between theory and inference. Their effects could be tracked. Their presence could be suspected. Their masses could be estimated. But the near-horizon region remained psychologically distant, almost sacred in its inaccessibility. The Event Horizon Telescope broke that distance, not by making black holes simple, but by making them measurable at the scale where the real weirdness begins. And that is why the engineering story cannot remain separate from the physics story. The Earth-sized eye was not built merely to admire a ring. It was built to interrogate a regime where general relativity plasma dynamics and the limits of observation collide. The image is historic, yes, but the deeper achievement is that humanity learned to force clarity out of one of the least cooperative environments in the universe. Which means the next question is no longer how the picture was made. It is what that picture and later refinements of it begin to reveal about the invisible architecture threading the plasma around M87 star. The magnetic fields that may turn a glowing ring into the mouth of a far larger engine. The image of M87 star becomes more dangerous to simple thinking every time astronomers look at it in a new way. First, it is a shadow. Then it becomes a lensed ring. Then it becomes a relativistic flow pattern. And then another layer appears, one that the original image only hinted at, but did not yet expose directly. The region around the black hole is not merely hot and fast. It is threaded, structured, disciplined by something invisible strong enough to help organize chaos at the edge of a supermassive abyss. That hidden architecture is magnetic field, and once it enters the story, M87 star stops looking like a furnace around a dark object and starts looking like a machine. This matters because hot gas alone does not explain what M87 does to its environment. The galaxy is famous not just for harboring a black hole, but for launching a giant jet that blasts outward across thousands of light years. A black hole can swallow matter. That part is easy to say. But swallowing is not enough to explain collimation direction or sustained outflow on such extraordinary scales. Something has to guide energy. Something has to channel plasma. Something has to impose order where violent turbulence should otherwise smear everything into a broader mess. For years, the strong suspicion was that magnetic fields near the black hole were playing that role. Suspicion, however, is not the same as evidence. The original image of M87 star showed brightness and shape, but not yet the deeper organization hidden in the light. That is where polarized light changes the story. Light does not only carry intensity, it can also carry orientation. When radiation is emitted in magnetized environments, the polarization of that light preserves clues about the magnetic field structure threading the emitting plasma. In other words, the glow around the black hole is not just illumination, it is testimony. If you know how to read the polarization pattern, you can infer something about the invisible field lines shaping the flow. That is exactly what later EHT observations began to reveal. Near M87 star, the light is not randomly polarized, as it would tend to be in a scene dominated purely by disorder. Instead, the pattern indicates strong organized magnetic fields close to the black hole. This is a profound shift in the story. The easy explanation for the ring is glowing gas under gravity. The real explanation is glowing gas under gravity and magnetic discipline. Gravity pulls matter inward. Magnetism helps decide how that matter behaves while it is still outside the horizon. The black hole is not acting alone. It sits inside an electromagnetic system with enough coherence to leave a readable imprint in the escaping radiation. That should be unsettling in the best way, because it means the region around M87 star is more structured than raw violence would suggest. We are not just looking at destruction. We are looking at organization under almost impossible conditions. That organization matters most because of the jet. M87's jet is one of the largest and most famous in the nearby universe, extending outward from the galactic center with enormous persistence and power. The jet is the visible proof that the black hole's immediate surroundings are doing more than merely heating up and disappearing inward. Somehow, a fraction of the energy near the hole is being redirected into coherent outward motion. Theories had long suggested that strong magnetic fields near a spinning black hole or within its accretion flow could help extract energy and launch such outflows. The polarized observations of M87 star do not solve every detail, but they sharpen the plausibility of that picture dramatically. They show that the required invisible framework is not a speculative convenience. It is present near the very place where it needs to be present. This is where the image of M87 star stops being just a test of general relativity and becomes a portal into plasma astrophysics at its most extreme. A black hole is often treated as though gravity explains everything important about it. Gravity explains the shadow. Gravity explains the event horizon. Gravity explains why light paths are bent and why matter can be heated to extraordinary energies near the center. But gravity by itself does not give us a full account of what the environment actually does. The real region near M87 star is not empty geometry. It is matter-motion field turbulence and feedback all tangled together. Polarized light reveals that the tangle is not random. There is order inside the violence. There is direction inside the brightness. There is architecture inside the glow. And that architecture may be one of the reasons the black hole can behave not merely as a sink, but as an engine. This also reframes the emotional meaning of the ring. Without polarization, the image is already astonishing, but it still risks being consumed, a symbol, a dark center surrounded by fire. With polarization, the image becomes harder, more technical, more alive. It no longer merely says that a black hole exists here. It says that invisible structures near the edge are strong enough to shape how matter falls and how energy may leave. The visible ring is no longer enough on its own. It becomes the front surface of a deeper and more disciplined system. And that makes M87 star more impressive, not less. It means the first black hole ever imaged is not only an object of extreme gravity, it is a site where gravity and magnetism combine into a regime still being decoded. The story on the surface is a ring. The story underneath is a working machine. But once that machine comes into focus, another problem follows immediately. Strong magnetic fields may help explain how M87 star launches and organizes its jet. Yet the existence of the jet creates a larger contradiction that the mind cannot ignore. How can a region centered on an object defined by no escape participate in one of the most spectacular acts of expulsion in the nearby universe, the black hole traps, light traps, matter traps, futures? And yet, from its neighborhood, comes a beam that crosses space on a galactic scale. The next layer is no longer about whether the system is organized. It is about how something built around capture becomes a source of directed release. The most famous part of M87 star is the dark center and its ring. But the ring is the smallest honest part of the story. That is the next correction. The image that made history is concentrated, intimate, almost quiet. A tiny, bright loop enclosing a deeper blackness. It feels contained. It feels local. It feels like the whole drama is happening within a compact sealed chamber at the center of a galaxy. But M87 has been telling a much louder story for a very long time. From its core emerges a relativistic jet, a colossal beam of matter and energy that stretches outward across thousands of light years, visible across many wavelengths, carving its presence into the galaxy and beyond. The black hole image gave the world the mouth of the machine. The jet reveals the machine's reach. This matters because it destroys the comforting idea that black holes are merely endpoints. A black hole is easy to imagine as cosmic termination, the place where matter falls in and the story ends. That is the surface version. The deeper version is more difficult. Black holes do end things for the matter that crosses the horizon, but the region around them can become one of the most effective engines in the universe. M87 star is not just a sink. It is the center of a system that helps launch an outflow so large that it dwarfs the scale of the image that made the black hole famous. The shadow is horizon-sized. The jet is galactic. The first image teaches you where the edge is. The jet teaches you that the consequences do not stay there. This is the contradiction that makes M87 star more than a visual triumph. How can an object defined by no escape sit at the heart of a structure that looks like escape made visible? How can the same environment that traps light also participate in launching something across interstellar and even intergalactic distance? The obvious explanation is that the black hole simply spits material back out. But that is not really what the best current picture says. Matter crossing the event horizon is lost from the outside universe. The jet is not a hose connected to the singularity. It is produced outside the horizon in the black hole's surrounding system, where infalling plasma spin and magnetic fields interact under extraordinary conditions. That distinction is essential. The black hole does not need to violate its own defining nature to help power the jet. The engine operates at the edge, not from a return path out of the abyss. Once that is understood, the scale of the achievement becomes harder to ignore. The jet is not a vague plume or an accidental leak. It is narrow, extended, and coherent across absurd distances. That coherence is the real shock. In ordinary, violent systems, energy tends to spread, disperse, and thermalize. Explosions expand in all directions. Turbulence dissolves neat structure. Yet here, near one of the most chaotic environments, imaginable nature builds a beam. It organizes outward motion so effectively that the central region of M87 influences space far beyond the tiny scale where the black hole's shadow lives. This is why the jet is not an accessory to the black hole story. It is one of the strongest proofs that the region around M87 star is not merely destructive. It is structured enough to do work across cosmic distances. And that is where the human scale sneaks back in. Because the image of M87 star can feel abstract, remote, almost ceremonial in its grandeur. A faraway galaxy, a giant black hole, equations holding up under extreme conditions. But the jet reintroduces consequence in a more visceral way. It tells us that what happens near the event horizon does not remain a local curiosity for theorists. Energy released and organized there can affect the host galaxy itself, stirring gas-heating environments, altering how matter behaves on much larger scales. The central black hole is not simply sitting in the nucleus like a passive monarch surrounded by scenery. It participates in the life of the galaxy. This is the broader pattern modern astrophysics keeps uncovering. Supermassive black holes are not merely the strange dark leftovers of cosmic evolution. They are entangled with the systems around them. They're feeding their output and their feedback, matter to galaxies. M87 star dramatizes that truth with unusual clarity because the jet is so spectacular and the black hole is now imaged so directly. The small ring and the immense beam belong to the same system. That pairing should feel almost impossible. It is as if one were shown the glowing mouth of a furnace and then asked to absorb the fact that its effects stretch across a kingdom. The mind wants proportionality. It wants the visible source to match the visible consequence. But black holes break that expectation. A compact central engine can dominate scales wildly larger than itself, and that changes the emotional meaning of the first image again. The ring is no longer just evidence that a black hole exists. It is the entrance to an explanation for why M87 has looked active, violent and engine-like for so long. The image and the jet complete one another. The ring says there is a deep gravitational regime here. The jet says that regime is not silent. Still, even this larger picture remains incomplete. Knowing that the jet is launched from outside the horizon does not yet tell us exactly how energy is transferred, collimated and sustained. It does not fully settle the role of black hole spin versus accretion flow, or where the decisive leverage is coming from in the system. The jet widens the scale of the story, but it also sharpens the mechanism problem. Because once it becomes clear that M87 star is not merely consuming matter, but helping organize power on galactic scales, the next question becomes more severe than ever. If the beam is real structured and persistent, then something near the black hole is not just surviving chaos. It is extracting order from it. And that means the next layer is no longer about the existence of the jet. It is about the hidden transfer of energy that makes such a jet possible at all. The jet from M87 star is not impressive because it exists. The universe is full of outflows, winds, flares, eruptions, and violent releases of energy. What makes this one extraordinary is that it seems to emerge from a system centered on the most one-way object in nature, and yet behaves like a precision engine. That is the deeper contradiction now. By the time the story reaches the jet, the easy myths have already failed. The black hole does not simply suck everything in like a vacuum cleaner. It does not fire matter back out from inside the event horizon. It does not break its own rules to create a cosmic loophole. The real explanation is more severe and more beautiful. The power is extracted outside the horizon in a narrow region where infalling plasma, twisted magnetic fields, and the rotation of space-time itself may combine into one of the most effective energy transfer systems in the universe. This is where M87 star stops looking like a destination and starts looking like infrastructure. The first image proved a shadow. The polarized observations suggested magnetic order near the edge. The jet proves that whatever this system is doing, it is not merely trapping matter, it is processing it. The crucial word here is spin. Real black holes are not expected to sit motionless in space-time like static holes cut into the universe. They inherit angular momentum from the matter and collapsed stars that formed them, and from the long history of gas and mergers that grew them afterward. A spinning black hole does something stranger than simply rotate as an ordinary object rotates. It drags space-time around with it. The region near the hole is forced into motion. This is not metaphorical. The geometry itself is being twisted. That matters because a rotating black hole stores enormous energy in its spin, and the natural question is whether the surrounding system can tap that reservoir. For decades, theorists have argued that under the right conditions, the answer is yes. Not by reaching inside the horizon and pulling energy back out, but by exploiting the physics just outside it. In broad terms, magnetic fields anchored in the surrounding plasma can thread the region near the black hole. If the hole is spinning and the field structure is strong and ordered enough, the rotation can wind those fields, accelerate particles, and launch electromagnetic energy outward along the poles. This is the essence of the leading picture often associated with the Blandford-Znajek process. The name is technical. The underlying idea is not. A spinning black hole does not shine by itself, but its rotation may help power a surrounding electromagnetic machine. That is a radical claim, and it has to be handled carefully. We do not have a tiny probe hovering beside M87 star measuring every field line in real time. We infer the mechanism from theory simulations, polarization data, the structure of the jet, and the behavior expected from relativistic magnetized accretion flows. So the honest statement is not that every detail is settled. It is that the evidence points strongly toward a picture in which black hole spin and magnetic fields are deeply entangled in powering the outflow. The easy explanation fails again. The jet is not simply hot gas sprayed upward by pressure alone. It appears to be a system that converts gravitational infall and rotational energy into directed large-scale power. That distinction matters because it raises the black hole from local object to systems-level agent. M87 star is not only consuming nearby matter, it is participating in the conversion of mass motion and field into a beam that can carry influence far beyond the horizon-scale region. In that sense, the black hole is not acting like a mere endpoint of collapse. It is acting like the center of an energy economy. Matter falls inward. Angular momentum is redistributed. Magnetic fields are amplified and wound, and some fraction of the available energy leaves in organized form. What emerges is not a contradiction of the black hole's nature. It is the harshest possible use of its environment. The trap becomes part of an engine. The no-return zone does not need to give anything back. Everything important happens just before the final loss. The event horizon still keeps its promise. Cross it, and you do not return. But the region outside it becomes one of the last places in the universe where order can be extracted from catastrophe with astonishing efficiency. The black hole does not relent. The surrounding plasma learns to exploit the conditions it imposes. That is why the jet is so narrow and so persistent. Random violence alone would not be enough. There has to be a guiding structure, and the evidence keeps pointing back to magnetic fields under rotational stress. This is also why M87 star matters beyond its own fame. It gives astrophysics a place where theories about energy extraction from spinning black holes can be confronted with data instead of remaining elegant speculation. The ring constrains the geometry. The brightness asymmetry constrains the flow. The polarization constrains the field structure. The jet constrains the power and direction. Put together, they describe not a static relic, but a working central engine. Because a black hole-powered jet is not merely a dramatic local feature. It is a mechanism by which the center of a galaxy can communicate with scales far beyond itself, dumping energy into surrounding gas, preventing cooling in some regions, stirring matter, and helping regulate the broader environment. The black hole's immediate victory over infalling matter becomes a larger intervention in galactic life. The first image looked like the triumph of seeing an object. The deeper truth is that M87 star is not an object in isolation at all. It is a node in a system of feedback. It takes in matter locally and helps shape conditions non-locally. It is darkness at the center and influence at a distance, which means the real consequence of understanding M87 star is not simply that we know a black hole image can be made. It is that the dark center of a galaxy may help govern the fate of the galaxy around it, forcing the story to widen once more from the physics of the edge to the consequences for the whole system that edge belongs to. The black hole at the center of M87 is not important only because it is extreme. It is important because its extremity does not stay contained. That is the next widening of the story. By now, the image of the ring has already been transformed several times. What first looked like a picture of darkness became a shadow shaped by gravity, then a lensed emission structure, then a relativistic flow pattern, then the front edge of a magnetized engine. But even that description is still too local. It keeps the drama near the event horizon, as though the deepest truth of M87 star lies in the small region where light is bent, plasma glows, and the jet is launched. The real problem is larger. The black hole does not merely sit at the center of a galaxy and perform an exotic private act of physics. It participates in regulating the environment around it on scales so large that the image of the ring starts to feel almost misleadingly intimate. The black hole is tiny compared with its host galaxy. The host galaxy is tiny compared with the cluster environment around it. And yet the influence of the central engine propagates outward across those scales with consequences that can shape the fate of matter far from the horizon. This is where black hole physics stops being a story about strange objects and becomes a story about governance. Galaxies are not static islands of stars frozen in elegant balance. They are ecosystems of gas radiation gravity, cooling heating collapse and feedback. Gas can cool, condense, and fall inward. Stars can form from that cooling material. Matter can accrete toward the central black hole. Energy can then be released back into the surrounding medium through radiation winds and jets. This looping relationship is what makes supermassive black holes so consequential. They do not have to be large compared with the whole galaxy in order to matter. They only need access to an energy conversion mechanism efficient enough to affect the gas on which galactic evolution depends. M87 star appears to have that access. Its jet is not just a visual spectacle. It is a delivery system. It transports energy outward into the galactic and cluster environment, disturbing heating and displacing surrounding material. That means the black hole can interfere with the simple expectation that gas in a giant system should just cool, settle, and make more stars indefinitely. The obvious explanation for a massive galaxy is more matter, more cooling, more star formation. The real explanation is more antagonistic. Central black holes can act as a brake. They can inject enough energy into their surroundings to prevent gas from cooling as efficiently as it otherwise would. In that sense, the black hole is not simply fed by the galaxy, it can also discipline the galaxy. This is one of the most important reframings in modern astrophysics. For a long time, black holes were treated as interesting endpoints, curiosities of general relativity, or exotic compact objects living at the edges of stellar death and galactic nuclei. Now they are understood as participants in structure formation and galactic history. Their growth correlates with properties of the galaxies that host them. Their activity can influence star formation rates. Their jets can inflate cavities in surrounding hot gas and deposit mechanical energy over enormous distances. They are not the whole story of galaxy evolution, but they are too central to be treated as decorative monsters lurking in the middle. M87 star dramatizes this better than almost any other black hole, because the evidence arrives on so many levels at once. The ring reveals horizon-scale gravity. The polarization points to ordered magnetic fields. The jet reveals outward power. The host galaxy reveals the context in which that power matters. The object, the engine, and the consequence all sit in one continuous chain. That continuity is what gives M87 star such intellectual force. It collapses the distance between abstract theory and astrophysical consequence. This should also change the emotional meaning of the first image. The public saw a ring and understandably felt awe at a direct confrontation with one of the darkest predictions in physics. But the ring is not just an endpoint of human curiosity. It is an entrance to a system story. If the black hole at the center of M87 helps regulate how energy moves through the surrounding environment, then the image is not merely about seeing an object that had once been invisible. It is about identifying a control point in a larger cosmic structure. The shadow is local. The consequences are not. And the scale mismatch is the point. A compact object smaller than the solar system can influence gas distributions, thermal histories, and the conditions for future star formation across a region vastly larger than itself. Human intuition hates this. It wants influence to scale with visible size. But the universe keeps demonstrating that compact, efficient engines can dominate larger systems when the energy conversion is violent enough and the coupling is persistent enough. Black holes are among the purest examples of that principle ever discovered. Yet even this widening of the story leaves something unresolved. To say that M87 star affects its environment is not the same as saying we fully understand the balance sheet. How exactly is the power divided between radiation, jet energy, turbulence, and heating? Over what timescales does the feedback remain stable? How does the black hole's own feeding cycle modulate the violence it returns to the galaxy around it? These are not decorative uncertainties. They are the pressure points of the whole framework. Because once a black hole is understood as a regulator rather than a mere devourer, the story can no longer be confined to what it is. The deeper question becomes, what kind of universe allows local darkness to become system-level order? And that forces the narrative into an even harder reframing. M87 star is no longer just evidence that black holes exist, or even that they can power jets. It is evidence that the universe can route consequence through hidden central engines, meaning the real story was never only the object at the center. It was always the structure built around its influence. By the time M87 star becomes a regulating engine in the mind, the first image has already ceased to be just an image. That is the next and perhaps most unsettling reframing. At the start, the story seems simple enough. Astronomers took the first picture of a black hole. Then the phrase begins to break apart under its own success. The black hole is not seen directly in visible light. The dark center is a shadow, not a surface. The ring is lensed and relativistically weighted emission, not a literal border. The final picture is reconstructed from sparse interferometric data, not captured as an ordinary photograph. Polarization reveals invisible magnetic structure. The jet reveals consequences far beyond the compact central scale. One by one, every intuitive category that made the image feel familiar collapses. What remains is more powerful than familiarity ever was. M87 star forces. A revision not just of what a black hole is, but of what it means to see an object at all, when the object's most important properties can only appear through the distortions it causes in everything else. This is why the phrase first black hole image is both correct and insufficient. It is correct because a stable horizon-scale image-like reconstruction of the black hole environment really was made, and it confirmed a predicted structure of astonishing importance. But it is insufficient because it suggests a neat continuity between ordinary visual experience and one of the most indirect observational achievements in the history of science. A chair is seen by reflected light from its surface. A mountain is seen by the sunlight it blocks, reflects, and colors. Even a distant star presents itself as a source. M87 star does none of that. It is known through controlled absence, redirected light dynamical brightness, and inferential discipline. In a deeper sense, the black hole is visible because the universe fails to hide all the consequences of its invisibility. That is a very different model of sight. The obvious explanation for science imagery is that better instruments show us more of what is out there. The real explanation is more radical. Sometimes better instruments force us to invent a new relationship between appearance and reality. M87 star is one of those cases. The image does not simply extend human vision farther into space. It changes the epistemic contract. It tells us that in the most extreme environments, an object may only become accessible when we stop demanding that it present itself directly, and instead learn to read its effect on geometry, plasma polarization, and causality. That is a profound shift, because it places black holes in the company of the hardest kinds of scientific objects, things that are not available to naive seeing, but are nonetheless constrained so tightly by theory and data that their hidden structure becomes undeniable. This also explains why the first image of M87 star landed so forcefully in culture outside astrophysics. The picture seemed to offer a direct encounter with one of the deepest boundaries in nature, but the reality underneath was even more philosophically potent. Here was an object whose essence includes a region from which no information escapes in the ordinary sense, yet the scientific method still found a way to anchor that essence to measurable form. The image did not dissolve mystery, it civilized it. It brought one of the harshest predictions in theoretical physics into the domain of disciplined observation without pretending that the underlying reality had become simple. That balance is rare. Many discoveries either reduce wonder by making the world more ordinary or inflate wonder by remaining too vague to constrain. M87 star does neither. It stays weird and becomes concrete. That is why the image matters as a turning point. Before it, black holes were overwhelmingly known through indirect dynamical evidence, X-ray emission jet phenomena, stellar motions, and theory. After it, the near-horizon region itself becomes something humans can begin to map. Not perfectly, not exhaustively, but genuinely. The word map is important here. A map is not the territory, but it is more than a symbol. It is a structured translation from one domain into another. The black hole image is exactly that, a translation from interferometric observables and relativistic radiative structure into a human-readable pattern that preserves deep physical truth. Once that is understood, the image becomes harder to trivialize and harder to romanticize. It is not merely a blurry triumph. It is not merely a sacred icon of science. It is a successful compression of a brutally difficult reality into a form that human minds can hold long enough to keep asking better questions. That final point matters because M87 star is not just the culmination of a long search. It is a beginning. The first image does not end the black hole story by settling what these objects are once and for all. It begins a new phase in which horizon-scale observation can confront theory more directly. Each new observation, each improvement in dynamic imaging, polarization, wavelength coverage and simulation does not merely add detail to a known portrait. It changes which kinds of questions can be asked with scientific seriousness. Once the invisible edge can be mapped, debates about magnetic structure flow, geometry, spin influence, and jet launching become less speculative and more empirical. This is the larger hidden victory of M87 star. The image is not just the answer to an old question. It is the opening of a new frontier. And that frontier is still under pressure because the very success of the image only sharpens what remains unresolved. We can read the shadow, but not the singularity. We can infer magnetic order, but not every field line. We can model spin-powered outflows, but not declare every mechanism closed. The breakthrough is real. The incompleteness is real too, which means the next layer cannot be triumph alone. It has to be limitation. Because M87 star becomes most revealing precisely at the point where the image proves both how much has been reached and how much still lies beyond the edge of what even a planet-sized eye can finally know. The first image of M87 star is powerful, partly because it shows so much, but its deeper power comes from what it cannot settle. That is the next hard turn. After the ring, the shadow, the magnetic structure, the jet, and the widening system-level consequences, there is a temptation to treat M87 star as a conquered object, one more mystery now reduced to data and interpretation. The temptation is understandable. Human beings like decisive thresholds. We crossed one in 2019. A black hole stopped being only a theoretical necessity and became something with horizon-scale observational form. But crossing a threshold is not the same as exhausting a frontier. In fact, the better M87 star is measured, the more precisely its unanswered questions begin to hurt. The obvious explanation is that we now know what a black hole looks like. The real explanation is harsher. We now know enough to see how much of the real story is still hidden behind the part that can be imaged. Start with the most brutal limit. The image tells us about the near-horizon region. It does not tell us what the singularity is, or even whether the classical singularity is the right way to think about the true interior structure at all. General relativity drives inward toward a place where curvature becomes effectively infinite, and the theory ceases to be a complete guide. That has always been the deep embarrassment inside black hole physics. Our best theory of space-time predicts its own breakdown at the core of one of the most important objects in the universe. M87 star does not solve that problem. It dramatizes it. The image brings us right up to the edge of the regime where theory becomes observationally anchored and then stops. The horizon is visible in consequence. The interior remains behind an absolute censorship. The black hole lets us map the border of ignorance with exquisite discipline, but it does not let us cross it. Even outside the horizon, the uncertainties remain severe. The spin of M87 star is likely central to the whole engine story, yet its exact value and the details of how that spin couples to surrounding plasma are not simply read off the image like labels on a machine diagram. They are inferred through models, simulations, polarization structure, jet behavior, and the consistency of different theoretical frameworks. That is strong science, but it is not omniscience. The geometry of the accretion flow is still debated in important ways. The distribution of matter, the role of turbulence, the thickness of the flow, the dominance of electrons versus ions in shaping emission, the exact topology of the magnetic field, the location and efficiency of jet launching, all of these remain active terrain. The image is a breakthrough, not a surrender document from nature. This matters because black holes create a dangerous kind of overconfidence in the imagination. They are so dramatic, so iconic, so mathematically forceful that once an image exists, people want finality. But M87 star resists finality at every level. The ring is time-averaged rather than perfectly frozen. The brightness pattern reflects dynamics rather than a settled shell. The polarized signal reveals order, but not every hidden line of force. The jet demonstrates organized power, but not every step in the conversion chain from inflow and spin to outward beam. Even the image itself depends on reconstruction choices, disciplined by data, not on direct visual access in the ordinary sense. The object is measurable, but never naively given. That is the cost of studying a black hole honestly. It keeps forcing science into a posture of disciplined partial sight. There is another pressure here, and it is perhaps the deepest of all. Black holes sit at the boundary between general relativity and quantum physics, and those two great frameworks still do not fit together cleanly in the most extreme regimes. M87 star does not merely test Einstein. It also reminds us of where Einstein is not enough. The horizon scale can be modeled with relativistic gravity and plasma physics to remarkable success. Yes. But the full black hole story eventually runs into information entropy, Hawking radiation quantum states, and questions about what space-time itself is at the smallest scales. M87 star does not evaporate on any practical timescale, and the famous information paradox is not something the ring image resolves directly. Yet the black hole's observational reality makes those deeper theoretical tensions harder to quarantine as abstract speculation. The object is real. The horizon-scale behavior is real. The unresolved conceptual pressure is real too. This is why the success of black hole imaging is not comforting in the way a solved problem is comforting. It is clarifying in the way a sharpened problem is clarifying. We no longer argue about whether objects like M87 star occupy the centers of galaxies. We argue more severely about how their environments actually work, how their spin is encoded in observable structure, how magnetic order survives in such violent conditions, and how the classical description of the whole relates to the deeper quantum story still waiting behind it. The achievement is real, The cost is that the frontier now has sharper edges, and those edges matter beyond astrophysics. Because whenever science reaches a place where the visible evidence is strong, but the underlying ontology is still incomplete, the meaning of the object begins to widen. M87 star is no longer just a black hole. It becomes a reminder that the universe allows us to approach some truths with extraordinary precision while withholding the final layer behind them. That is not failure. It is the normal condition of deep knowledge. But it changes the emotional register of the story. The ring is not the end of mystery. It is mystery under discipline. And once that is understood, the next layer almost announces itself. The real significance of M87 star may not lie only in what it tells us about one giant black hole in one distant galaxy, but in what kind of universe produces objects that can be measured at their edge, remain hidden at their core, and still force human thought to expand around them. The deepest meaning of M87 star is not that the universe contains monsters. It is that the universe contains structures so extreme that they force intelligence to mature in order to describe them. That is the next widening, and it is larger than the black hole itself. By this point, the object at the center of Messier 87 has already broken every comfortable category that first made it seem understandable. It is not seen directly in the ordinary sense, yet it is imaged. It does not emit light from a visible surface, yet it shapes a luminous ring. It traps matter and forbids return, yet the region around it helps launch a jet across galactic scales. It is compact beyond common intuition, yet its consequences radiate outward into a system vastly larger than itself. Each step in the story has done the same thing to the mind. It has taken a familiar word and made that word insufficient. Picture becomes reconstruction. Edge becomes causal boundary. Darkness becomes measurable geometry. Object becomes engine. Engine becomes regulator. The surface story keeps collapsing into deeper structure. That is why M87 star matters beyond astrophysics. It is one of the clearest modern examples of a reality so difficult that knowing it requires a civilization to move past naive seeing, naive scale, and naive causality all at once. Human intuition evolved for thrown stones, daylight horizons, faces, bodies, weather, and distance measured by walking. Even science begins by refining those instincts, extending them with instruments, math, and experiment. But every so often, the universe presents an object that cannot be understood by extension alone. It has to be understood by transformation. M87 star is one of those objects. To study it, humanity has to build an Earth-sized I trust inference over immediacy, accept that an image can be real without being ordinary, and learn to read absence lensing, polarization, and relativistic asymmetry as evidence of a coherent thing. In that sense, the black hole is not only a test of physics, it is a test of the methods by which a species makes reality legible to itself. The obvious explanation for scientific progress is that over time, humans simply see more clearly. The real explanation is harder. Sometimes progress means giving up the fantasy that reality must look like itself in order to be known. A black hole does not present a convenient face. It presents consequences. It presents constraints. It presents a pattern of allowed and forbidden paths. To know it is to accept that truth may arrive through distortion rather than direct display. That lesson is larger than M87 star. It belongs to the whole modern scientific project, from fundamental particles to space-time to the deep history of the cosmos. But M87 star dramatizes it in unusually pure form because the object seems at first to promise nothing at all. A place where no light escapes should be the perfect insult to observation. Instead, it becomes one of observation's greatest triumphs. That reversal is almost philosophical in its force. It says the universe is not obligated to be simple, local, or intuitive in order to be knowable. It only has to leave consistent traces. Intelligence does the rest. There is another layer beneath even that. M87 star also reveals something severe about power in the universe. Human imagination tends to associate power with visibility, the brightest object, the largest shape, the loudest event, the most obvious motion. But black holes invert that instinct. The central object is dark. The horizon is hidden. The singularity, if that language is even right, is sealed from view. And yet, around that hidden center emerges one of the most consequential engines in the nearby cosmos. Power here is not theatrical. It is structural. It resides in compactness, in efficiency, in the ability of a small region under extreme conditions to reorganize matter and energy across scales enormously larger than itself. That pattern echoes far beyond black holes. It belongs to stars' nuclei compact remnants and perhaps to the architecture of reality more broadly. The deepest engines are not always the most visibly grand. Sometimes they are the most concentrated, the most disciplined, and the most hidden. M87 star makes that principle visible in one of its harshest forms. It also changes the emotional posture of ignorance. Before the first image, black holes could still occupy a partly mythic space in culture, hovering between theory, metaphor, and speculative awe. After M87 star awe remains, but it has to share the room with method. The black hole has not been domesticated, but it has been anchored. That changes what mystery means. Mystery is no longer the vague darkness that surrounds an absent object. It is the sharpened remainder after measurement. It is what survives once the ring has been mapped. The polarization read the jet traced, and the theory forced to confront reality. This is a better kind of mystery. Harder, more demanding, less decorative. It does not invite fantasy so much as deeper work. And that may be the real legacy of M87 star. Not simply that it gave humanity the first image of a black hole, but that it converted one of the most intimidating ideas in physics into a frontier that can now be approached in stages, each answer exposing a deeper question beneath it. The black hole becomes a ladder into harder knowledge, but ladders matter because they lead somewhere. M87 star has shown that the edge can be measured, the environment can be decoded, and the hidden engine can be constrained. The final pressure now falls on meaning itself. If a dark object at the center of a giant galaxy can become this readable without ever becoming simple, then the real story of M87 star is not only about one black hole. It is about the kind of universe we inhabit, a universe where the most forbidden places may still be legible at their boundary, where absence can become evidence, and where the path from ignorance to understanding does not move by clearing away mystery, but by giving it sharper and more truthful form. The first image of M87 star begins as a picture of darkness, but it ends as a picture of how far knowledge can go before darkness changes meaning. That is the final synthesis. At the beginning, the black hole seems to present the most primitive challenge imaginable. Here is a place that does not let light escape, a region built to deny the oldest tool of human understanding. Sight fails, return fails, direct access fails. The object appears to stand for limit itself. That is why the image struck so hard when it first appeared. It seemed to show that even the universe's most forbidden structures could finally be dragged into view. But after everything M87 star has forced us to learn, that first reaction is no longer enough. The ring is not victory over darkness in any simple sense. It is the record of a negotiation with darkness, a disciplined encounter in which reality gives away only what its own laws cannot help but reveal. That is the more mature truth. The black hole does not surrender its center. It does not become transparent. It does not stop being a place where classical intuition breaks, where the event horizon seals the interior from ordinary inquiry, where the deep problem of the singularity or whatever replaces it still waits beyond the reach of present theory. And yet, around that refusal, something extraordinary happens. Gravity lenses light into geometry. Motion writes itself into brightness. Magnetic fields leave their trace in polarization. Jets carry consequence across galactic distances. Sparse data harden into image. Theory confronts measurement. The forbidden object becomes legible at its edge without ceasing to be forbidden at its core. That is why M87 star matters more now than it did on the day of the first image. In 2019, the world saw a black hole. In the fuller story, humanity learned that one of the most inaccessible things in existence could still be made scientifically answerable without being reduced to ordinary experience. That difference is enormous. It means the image is not important because it made the black hole familiar. It is important because it proved that familiarity is not the standard for truth. The universe does not owe us surfaces, direct views, or intuitive scales. It only owes consistency. And if consistency exists, then disciplined intelligence can begin to climb. That is the real transformation hidden inside M87 star. The first black hole image is not only about a black hole. It is about the terms on which reality allows itself to be known. This is why the ring does not diminish with repetition. The more it is reproduced, the easier it is to mistake it for a settled icon, a historical badge, a famous result already absorbed into the ordinary museum of human achievement. But the ring should resist that domestication. It is not a logo for science. It is a warning about scale, about inference, about what the deepest objects demand from those who try to understand them. It tells us that the universe contains places where the visible scene is shaped by trajectories that do not survive, where absence is measured more reliably than substance, where the edge of an object matters more than anything that can be seen within it, and where the consequences of a hidden center can dominate a galaxy. That is not just another discovery. It is a correction to how reality itself must be imagined. M87 star also restores something important to the meaning of progress. Progress is often imagined as the steady replacement of mystery with clarity, as though science works by draining the world of shadows until only mechanism remains. But black holes show a harsher and better pattern. Real progress often means learning how to describe shadows truthfully, not abolishing mystery, but forcing it into sharper form. Not pretending that the unknown has become small, but proving that even the unknown has a structure that can be tested. M87 star is one of the purest examples of that pattern ever produced. Its image does not end mystery. It disciplines mystery. It takes one of the darkest predictions in physics and turns it into a frontier with measurable boundaries, physical constraints, and real consequences. That is a more powerful achievement than simple explanation could ever be. And it leaves behind a final change in perspective. The black hole at the center of M87 is not merely a monster, not merely a machine, not merely a triumph of observation. It is a boundary object in the deepest sense, a place where relativity, plasma physics, magnetic structure, galactic evolution, and the philosophy of observation all meet. It is where a civilization discovers that even an abyss can be mapped. In part, that even invisibility can leave a pattern, that even the darkest object in the nearby universe can be made to answer questions carefully, incompletely, but undeniably. The image began as a ring around a silence. It ends as proof that silence is not emptiness. It is structure waiting at the limit of what can be read. And that is why M87 star, the first black hole ever imaged, does not close the story of black holes at all. It opens the era in which the darkest things in the universe stop being merely imagined and begin at last to be measured, where they are strongest at the edge, where reality bends, light hesitates, and human knowledge learns how to look without ever fully crossing in. What M87 star finally changes is not just the picture humans have of black holes. It changes the standard by which reality is allowed to feel real. For centuries, the universe seemed most trustworthy, where it was brightest, nearest, most directly seen. M87 star breaks that instinct cleanly. It says the deepest truths may appear first as distortions, as missing paths, as brightness bent around a center that refuses to show itself. It says a thing can be darkest at its core and still leave a structure precise enough to test, measure, and return to again. That is why the first image never really was a finish line. It was a change in jurisdiction. Black holes no longer belong only to theory, metaphor, or awe. They now belong to observation at the scale where their strangeness actually begins. Not fully, not comfortably, but irreversibly. The shadow can be mapped. The ring can be compared against theory. The polarization can expose hidden order. The jet can connect the invisible center to consequences written across a galaxy. The abyss is still an abyss, but it is no longer silent in the old way. And that may be the most important part. M87 star proves that the universe does not become understandable by becoming gentle. It becomes understandable because even its most violent and forbidden places still obey enough order to be read by a patient intelligence. The black hole keeps its interior. It keeps its final secrecy. Yet around that secrecy, it leaves a geometry, a pattern, a discipline of evidence. And that is enough to change everything. So the first black hole ever imaged is not remembered merely because humanity saw darkness. It is remembered because humanity learned how to read what darkness does to the world around it, and in doing so came closer to the edge of reality than ever before.